Hello, you guys. This lesson today is on simplifying an algebraic expression. We are going to start this lesson with some vocabulary words. Today's vocabulary will include terms, like terms, combining like terms, and expression. And we have actually already defined expression in one of our other lessons. Remember, an expression is basically just a mathematical sentence. So let's start with the word terms and what it means to be a term in math. Up on the board, I have 6 different problems. When we talk about terms in math, the terms are what is separated by the addition or subtraction. So for question number 1, there would be 2 terms. 5x would be a term and 3x would be a term. Remember when we look at the term 5x, that is really 5 times x, okay? And when we look at the term 3x, that is really 3 times x. So it's really important for you to know that when a number is right next to a variable, there's actually implied multiplication there. Okay. Question number 2. When we look at this question, we have 2 terms. One of them is 3y. One of them is 10y. Question number 3. There would be 4 terms, 2x, 6, 7x, and 11. Okay, so remember when we're talking about terms, terms are what is separated by the addition and subtraction. So let's look at number 4. Let's count the number of terms that we have for number 4. So number 4 has an addition, a subtraction, addition, subtraction, addition. And remember the terms are what is separated by the addition and subtraction. So we have 5mn, which is really the same thing as 5 times m times n. We have 2 times m. We have 3 times n. We have 4 times n, m times n. We have 6m, and we have 4n. So for question number 4, there are 1, 2, 3, 4, 5, 6 terms. Okay, there's 6 terms for this one, 4 terms for this one, 2 terms for this one. Let's look at question number 5. There's an addition, addition, subtraction. So the number of terms for number 5 would be 1, 2, 3, 4. There are 4 terms. 4 times by x squared, 2x, 2 times x, 6 times by x squared, and 4 times x. Okay, let's look at the last one, number 6. We have 3 times m times n. We have a negative 2 times by n squared. We have a 4m. We have an 8mn, and we have a 7m. So for number 6, there are 5 terms. So one part of the definition of terms is that terms are separated by addition and subtraction. Another important part of our definition is that terms can be made up of just a number. If it is just a number, we would call it a constant. So if you look at number 3, we have 4 terms here, 2 times x plus 6 plus 7x minus 11. Okay, we have 2 terms here that are just numbers. We have 6 and 11. If a term is just a number, we call that a constant. Terms can also be made up of a number multiplied by a variable. Okay, in this case, if you have a number multiplied by a variable, the number part of the term is called the coefficient. So when we have this term right here, 5 times x, The 5 would be considered a coefficient. Okay, so the number part of the term is the coefficient, and obviously the variable part of the term we would call a variable, which we talked about in our last lesson. So we know terms can be just a number, which we would call a constant, like here, 6 and 11. Terms can be made up of a number multiplied by a variable. Remember, the number part of the term is called the coefficient. Terms can also be made up of a number multiplied by more than one variable. So 5 times m times n. I wrote m twice, didn't I? So 5 times m times n. This would be considered one term. The number part of the term is called the coefficient. Okay, so remember, terms can be separated by addition or subtraction. If there is just multiplication happening, that is the same term. Terms can also be made up of a number, and you could have a variable raised to a power. Like, for example, 4 times by x squared. This is one term. The number part of the term is 4, so that's called our coefficient. We have a variable of x, and in this case, x is being raised to the second power. So what that means is we really have 4 times by x times by x, okay? Remember, the power right here tells us how many times we multiply the base by itself. So I'm going to give you an example here. So if I give you this expression, 5 times by x squared plus 6x minus 2, and I ask you how many terms this expression has, you would tell me 3. 1, 2, 3. Okay, this expression has 3 terms. If I ask you what the constant of this expression would be, you would tell me 2. The constant of this expression is 2. Okay, remember, the constant is the term that is just a number. If I ask you what the coefficient of the term 5 times by x squared is, you would tell me 5. Oh, I'm going to run out of room. 5x squared. Okay, 5 is the coefficient. That is the number part of the term. Let me give you another example. Let's say I give you the expression 4mn minus 6m plus 2n minus 3. And I ask you to tell me how many terms this expression has. Well, this expression has 4 terms. 1, 2, 3, 4. Okay, so it has 4 terms. If I ask you what the constant of this expression is, you would tell me 3. 3 is the constant. If I ask you to tell me what the coefficient of the term 2 times n is, the coefficient would be 2. Okay. So let's go ahead and add on to our definition for terms. So we know that terms are separated by addition and subtraction. Terms can be a constant, so remember that's when a term is just a number, or made up of multiplication of a number and a variable or more than one variable. Okay, so I think we have a pretty good definition for terms, and hopefully you have a good understanding of what a term is and how to figure out how many terms are in an expression, and then also how to identify the constant and coefficient of each term. The next definition we're going to talk about is like terms. When we talk about like terms are terms that have the same variable or variables raised to the same power. So if I give you two terms, 2x and 5x, these would be like terms because they both have an x raised to the first power. If I give you the two terms 3x squared and 5x squared, these would be like terms because they have the same variable raised to the same power. If I give you two terms, 4mn and 3mn, these would be like terms because they both have a coefficient multiplied by the same variables, m times n. If I give you these two terms, 2x and 5x squared, these are not like terms. Even though they both have the variable x, this one is being raised to the second power, and this one is being raised to the first power. So they are not like terms. If I give you the two terms 4mn and 5m, these would not be like terms. This one has an m times n, and this one just has an m. So in order for terms to be like terms, they have to be the exact same variables raised to the exact same powers. So let's go back to this independent practice slide. As we look through here, we're just going to identify what the like terms are for each expression. So for question number 1, 5x and 3x. 5x and 3x are like terms. They both have a variable multiplied by x. Question number 2, 3y and 10y are like terms. They both are multiplied by a y. Let's look at question number 3. So for question number 3, we have 4 terms here. 2x and 7x would be like terms, okay? 2x and 7x are like terms. We also have 6 and negative 11 that are like terms, okay? They have no variables. So anytime you have constants, those would always be considered like terms. Let's look at number 4. We have 5 times m times n plus 2m minus 3 times n plus 4 times m times n minus 6m plus 4n. So let's identify the like terms here. Well, we have 5 times m times n. We have 4 times m times n. So 5mn and 4mn. Those are like terms. Okay. We also have 2m and we have a subtract 6m here. Okay, so those are like terms. 2m and 6m. And then we also have 3n and 4n. Those would be considered like terms. Okay, so remember, like terms are terms that have the same variables raised to the same powers. Let's look at number 5. So on number 5, we have 4 terms here. We have 4 times by x squared and 6 times by x squared. Those would be like terms. We also have 2x and 4x. Those would be considered like terms. Okay, let's look at number 6. We have a 3mn, we have an 8mn. Those would be like terms. We have a negative 2n squared, but we have no other terms that have an n squared. And we also have a 4m and a 7m. So those are like terms. Okay, so let's go back to our definition for like terms. Like terms are terms that have the same variable or variables raised to the same power. Now we're going to spend the rest of today's lesson talking about combining like terms. Okay, if two terms are like terms, you can combine them. That means that you can add or subtract them. Okay, that's what combine means. If they are not like terms, you cannot combine them. Okay, so when you are dealing with an expression and simplifying an expression, you can only combine things that are like terms. Okay, so let's go back to our independent practice slide, and we are going to work on combining like terms. So the way that you combine like terms is you add the coefficients and the variable or variables stay exactly the same. The tricky thing to remember is that whatever sign is in front of that term, that is the sign of the coefficient. Okay, so let's look at question number 1. We have 5x plus 3x. We can combine 5x and 3x and make that 8x. These are both like terms. Okay, and in order to combine like terms, we just add the two coefficients in front, and then the variable stays exactly the same. Question number 2, we have a 3y subtract 10y. Okay, so when we combine like terms, we're going to combine the coefficients of the like terms. Now, here's something that I want you to pay close attention to. Because there is a minus sign in front of this 10y, that actually makes this a negative 10. Okay, so when we combine 3y and negative 10y, all you're going to do is combine 3 with negative 10. So if you do 3 plus negative 10 in your calculator, you will need your calculator for this assignment. So 3 plus negative 10 would be negative 7 times by y. Okay, let's look at number 3. On number 3, we have 2x and 7x. Those are like terms. So we're going to combine the 2 and the positive 7. That's going to give us 9x. Okay. We also have, I'm going to go ahead and clear this off so we don't get confused. Okay, so we have a 9x. Okay, so we just took care of these ones, right? We just combined these. Now we also have a 6 and a negative 11. Okay, we have a 6, a positive 6, and because there's a minus sign in front of this 11, it makes it a negative 11. So in your calculator, when you combine 6 plus negative 11, you get negative 5. Okay, so this expression right here simplifies to 9x minus 5 after we combine the like terms. Let's look at number 4. Okay, so let's start with combining the 5mn and the 4mn. Remember that we're just going to add the coefficients. The variable or variable stays the same. So 5mn plus 4mn becomes 9mn. Sorry, I don't know why I keep writing an additional 9mn. There we go. Okay. We can also combine 2m. So there's a positive sign in front of that. So positive 2, and we have a negative 6. Because there's a minus sign in front of the 6m, that makes it negative. So in your calculator, when you do 2 plus negative 6, you get negative 4m. Okay, the last one, we have a negative 3 right here, a negative 3. We're combining that with a positive 4. So in your calculator, you would put in negative 3 plus 4, and that will give you plus 1n. Okay, so remember when you're combining like terms, you add the coefficients. The variable or variables stay exactly the same. Okay, let's look at number 5. 4x squared plus 2x plus 6x squared minus 4x. Okay, so our like terms, 4x squared and 6x squared, those would combine and we would get a 10x squared. We know that 4 plus 6 is 10. Okay, then we have a positive 2x and we have a negative 4, right? We have a minus sign in front of the 4, which makes it negative. So in your calculator, you're going to put in 2 plus negative 4. And that's going to give you a negative 2x. Okay, last one. We have 3mn. We have a minus sign in front of this 8mn. So when we combine these like terms, we're going to add the 3 and the negative 8. So in your calculator, if you do 3 plus negative 8, you get negative 5mn. Okay. Then we have a negative 2n squared. And there are no other like terms. So negative 2n squared. And then our last set of like terms for this expression is a 4m, positive 4. And then we also have a negative 7, right? Because 4m and 7m are like terms. There's a minus sign in front of the 7. So when we combine 4 with negative 7, we get negative 3m. Okay? So in order to combine like terms, the terms have to be like terms. Okay, that's super important. You can only combine things that are like terms. When you combine like terms, let's add to this definition, you add the coefficients and the variable or variables stay the same. Okay, so you don't change those. Okay, so you guys are ready for your quiz for this lesson. For each of these expressions, I want you to simplify the expression, meaning that you are going to combine the like terms. Please pay careful attention to the sign that is in front of the coefficient when you're combining like terms. Okay, so like for number 1, we have 2x, we have a 4y, but there's a minus sign in front of this 4. So when you combine the like terms here, remember that this would combine as a negative 4. Okay, for this one you have a negative 5m, so that's a negative 5, positive 6, negative 4, positive 2, positive 8, positive 3. So remember, when you're combining like terms, you need to pay attention to the sign that's in front of the coefficient, because when you're combining, you have to use that sign. Okay, so for question number 3, we have a 5, we have a 2, a positive 2, we have a positive 3, we have a negative 7, we have a negative 2, and we have a positive 3. Okay, so you guys go ahead and do this quiz on your own paper, and then just like the rest of the assignments, upload it to the assignment box. And if you guys have any questions, or if did not make sense to you at all, please come to class tomorrow and I will help you learn how to do this so that you can take and pass your quiz. If you understand how to combine like terms, take your quiz, I'll grade it, check your feedback, and then you'll be ready to move on to the next lesson. I hope you guys have a really great day. And like I said, if you have any questions, email me, call me, text me. I'm here for you. Okay, we're on the same team, and I really want you to be successful in math this year. So go ahead and finish your quiz and have a great day.